And now we are going to talk about real stoichiometry. And again, stoichiometry is any mathematical calculations in chemistry that involves moles. So you have seen part of this box already, and this box is from Mr. P's chemistry page. Thank you, Mr. P. I wonder if it's related to Mr. T. But anyway, so a stoichiometry will always involve a balanced chemical equation. And anytime you use the balanced chemical equation is actually indicated by this box here, this gray, blue, whatever color box you wish it to be. So it is basically a recipe for all types of reaction, and any math that we calculate from this is our theoretical numbers. Okay, and the reason why that is no reaction will ever go to 100% completion, right? So if I start with 20 grams of something, I will never get 20 grams at the end. We all know this. This is how it works, right? So it's kind of like when you earn money, you know, they always tax and nothing. You never get the whole amount at the end, right? So it may involve 1 step, 2 steps, or 3 steps. And the key here, you just need to figure out where you're starting from and where you're ending from. So if the unit that's given to you is a mass, let's say of mass of hydrogen, and the required answer is moles of something else aside from hydrogen, you need to understand that you're starting at mass and you're ending at moles. So in this case, you look at where you're starting from, and you can see anytime you use an arrow, that's 1 step. So in this case, you would be 1 step, 2-step problem. So a mass to mole problem is a 2-step problem. You can start anywhere here, and you can end anywhere. The main key when we involve stoichiometry and we use balanced chemical equations is you need to use this once. You need to use this once. You will never use the balanced equation twice. You will only use it once in a whole mathematical equation. Okay, so if I start with mass, end at mass, as you can see, there's 1, 2, 3 steps. If I started with moles and then with mass, as you can see, I started with moles, that means 1, 2 step. Okay, so you can start anywhere and anywhere, but the most steps that you will be required to do will be 3 steps, because if I start with particles and at particles, that's still 1, 2, 3. If I start with particles and in volume, it's 1, 2, 3 still 3 steps. And again, I hope that you remembered how to use this. If you go with an arrow, you use the ratio that's given. If you go against an arrow, you flip the ratio that is actually given. Okay, it's probably best if we actually do some problems. Okay, so we're going to move on. So how do you know you're going to be doing stoichiometry? Well, first of all, the giveaway is there's going to be a balanced chemical equation. For your purposes, to make your life a little bit easier, I will always give you a balanced chemical equation. I'm not going to trick you by starting you off with with an imbalanced chemical equation. I already know that this is a tough subject the way it is, especially with the compressed semester that we have. So we have a balanced chemical equation. So I could ask you any question pertaining to this, but here's one example. How many moles of carbon dioxide is produced when 1.8 moles of C7H16? Okay, this is actually heptane. Okay, it's 1 carbon less than octane, the thing that you put in your gas tank. So this is the starting unit given to you is moles. The ending unit that you need is moles. So this is a mole to mole problem, which only involves 1 step. I hope that makes sense. And all of this other things is extraneous information. I have to give you this because I need to make sure that there's actually enough oxygen taking part in the reaction. So I'm going to set it up. So I'm going to go 1.8 moles times, right? I'm starting here. So I write the moles, and then I'm going to go across, and now I have to write the ratio, okay, indicated here. The new substance, folks, I should never say folks, some of you get driven nuts by that. The new substance is the moles that is being asked. So CO2 is the new substance. C7H16 is the given substance. So in the balanced chemical equation, the ratios can be expressed by the coefficients. So the coefficient in front of carbon dioxide is 7. So that is mole of new substance. So in the balanced chemical reaction, there's 7 moles of carbon dioxide. And the mole of the given substance is heptane C7H16, and that is 1 mole. So this is again another little bit of a wrinkle on unit, or in this case unit cancellation or dimensional analysis. The moles of C7H16 cancels the moles of C7H16 that's in the denominator of the ratio. What unit do we end up with? Moles of CO2, and we need to follow significant figures again. The answer is 12.6, but the given number of significant figures is 2. So we look for first significant figure, second significant figure, number to the right is greater than 5. This 12 gets rounded up to 13. Okay, so we used it by identifying where we're starting from and identifying where we're ending from, and using the ratio indicated here. Again, new substance means what is being asked. Given is the mole or the substance adjacent or right next, succeeding the number that's given to you. Moving on. Same balanced chemical reaction. How many grams of water is produced when 2 moles of oxygen is used up with an excess of C7H16? Extraneous information again. Grams of H2O from 2 moles of O2. So we're starting at moles of O2. And we're trying to find grams. So grams, if you look at this table, goes all the way. This is grams, this is mass. So that means to say this is a 2-step problem. Okay, so again, we're starting with 2 moles of O2. We're gonna go to moles of water. Right? So 2 moles, so we're trying the moles of O2. So we're trying to eliminate the moles of O2, folks. Now, I don't write the moles of O2 because I'm just lazy at this point, okay? So if I cancel, where does this 8 and 11 come from? The 8 and 11 come from the balanced chemical equation. It says so right there. Use balanced chemical equation, okay? So the coefficient in front of water is 8. This is the new substance. The coefficient in front of oxygen, which is the given substance, is 11. So it's 8 over 11. Are we done yet at that point? No, because if we go one step, the answer that we get are moles, and the problem is asking for grams. Okay, so therefore we need to keep going, and guess what? This is something that you've done already. Molar mass of new, what's new? Water. What's the molar mass of water? 18 grams over 1 mole. This is always a constant. The 1 mole, please do not change this. This is always 1 mole over the molar mass. And if the answer is 26.1818 repeating, we need to do some rounding again because we have 2 significant figures. First significant figure, second significant figure, number to the right is less than 5. It remains 26 grams. Okay, 2-step problem. This is another like wrinkle to like a 2-step problem. So in this case, we're starting with grams and we're ending with moles. So we're starting with grams. So we're starting here. And we need moles of a new substance, so that means to say we're gonna end here. Okay, so the first step we already done before. It's 1 mole of carbon dioxide over the molar mass of carbon dioxide, which is 44.01 grams. All right, so the grams of CO2 cancels again. We are now left with moles of carbon dioxide. Are we done yet? No, because we're here. We need to get to here. And again, anytime you have a stoichiometry problem, you have to use the balance equation once. Always. Okay, so where does this 1 and 7 come from? This 1 and 7 come from the balanced chemical equation. Okay, the coefficient in front of C7H16 is 1. The coefficient in front of carbon dioxide is 7. And as you can see, the moles of CO2 cancel. What do we have left? Moles of C7H16. And obviously, significant figures come into play. And again, the significant figures is dependent upon the number that's given, which is 3 in this case. Right? So again, the key here is identifying where you're starting from and where you're ending from. Last but not least, this is the most complicated one, is grams of water is being asked. Grams of O2 is being given. So that means it's going to be a gram all the way to grams, which means it's going to be a 3-step problem. 1 step, 2 step, 3 step. Okay? I think that was actually a song from weddings. But anyway, moving on. So then we set it up, 65.5 grams given. We go to the moles. We've done this before already. 1 moles of given will be like underneath is the molar mass. 1 mole of oxygen is 32 grams of oxygen. How did I do that? Anytime you find molar mass, that's from the table of elements. Then the next step is using the balance equation. The coefficient of water is 8. The coefficient of oxygen is 11. So we're at this point of this, after that, then guess what? We go from moles to mass, and it's molar mass on top, 18 grams of water over 1 mole of water. And we do some rounding again because we need 3 significant figures. So the take home here, and this is going to be struggle, is identifying where you're starting at and where you're ending, right? What you're starting at is always going to be the number and the unit after the number. Where you're ending from is always going to be what's being asked with the unit. Okay? The substance behind the number is always the given. The substance behind what's being asked is always going to be the new substance. You will always use the balance equation, the coefficients from the balance equation once. At no point in stoichiometry will you not cross this box. All right? I hope this helps. We were going to be doing a lot more of this in class, but make sure that you also do your practice problems in your textbook.